There is still very much unexplored mechanism that may affect our weather system. It is linked with the atmospheric circuit. I am with Mei Mei from the British Antarctic Survey in the United Kingdom. She sees pressure effects in Antarctica, which she thinks relate to the action of atmospheric electricity. Hello, Mei Mei.
Hello.
What is atmospheric electricity and how does it work?
Well, in order to understand how it works, we use a conceptual model that we call the global atmospheric electric circuit. And this describes the electrical environment between the Earth's surface and the ionosphere. At any one time, there are about 1,000 thunderstorms that are occurring around the world, and together with electrified rain clouds, thunderstorm clouds act like a 250 kilovolt battery that drives a global electric circuit through the atmosphere. And this 250 kilovolt voltage difference, we call it the electric potential of the ionosphere. And everywhere away from these battery regions, in areas of blue sky and clear weather, tiny vertical currents flow downward from the ionosphere and through the air, and they pass through any cloud and aerosol layers on their way down to the Earth's surface.
What effects does this electric current have on weather?
Well, we see clear relations between the large-scale, day-to-day dynamics of the atmosphere and regional changes in this downward current. One of the effects we see is a connection between changes in the electric potential of the ionosphere and polar surface atmospheric pressure. And such changes in the electric potential can be caused by changes in the solar wind. There's evidence that this polar pressure effect can affect atmospheric planetary waves, and therefore also weather systems, and these impact on more highly populated areas than the remote polar regions.
Mm-hmm. And what happens when these electrical currents meet clouds on their way down?
Well, it's been suggested that this varying downward current of the global electric circuit leads to variations in the electrical charging of the water droplets and the aerosol particles in clouds. And this may slightly change cloud properties and therefore the wider atmospheric dynamics. We've already started to use computer models to see how charging of droplets and aerosols affects the cloud microphysics. And we've also started to look for significant observed changes to cloud properties, which are associated with the changes to the electric circuit. But there's still plenty of work to be done on these things.
Is there also an effect of this circuit on climate?
Well, we don't know the answer to that. We'd very much like to know. The advantage of looking on these daily timescales is that at least we can isolate the effects of the global electric circuit from the effects of other solar wind-driven mechanisms, because those act on quite different timescales. And also, with just a few years of data, we can get lots of examples of these electric circuit events. And I think that the effects on longer timescales are going to be a very exciting area of future research.
Thank you very much, Mei Mei.
Thank you.